Today we're going to be working with logarithmic functions. We're going to be converting them from a log into an exponential without using a calculator to assess. So I will only do just a handful of these, and then I'd like you to try it, and I'll show the answer key towards the end of this video. So let's take a look at this first one. When it comes to the properties, when it comes to a logarithm and trying to solve for a logarithm using your exponential, the reason why we can use the exponential is because they are inverses of one another. So one does something and the other one undoes it, kind of like a square and the square root. So for us, if we have a logarithm, so I'll just write just a random one. So log base x of y is equal to z. So two things we can do to solve this logarithm or to convert your log is one is the swoop property. So the swoop method, I should say. The first thing we want to always start with is your base. Your base of the logarithm is the number that's directly attached to the log itself. We're going to come up and around, tag the next value, and then land on that y. And the reason why the swoop method is nice is because it kind of shows you, okay, what we're coming and touching is the next one that we write. So the first thing we touched was the x value, raised to then the next value was z is equal to the very last value that we touched was y. And you'll notice that this is now an exponential. So we have x raised to the z is equal to y. So you'll see this in action. I don't typically use the swoop method, but some students like it, so I kind of show it. So the logarithm here has a base of 4. Notice that the 4 is directly attached to this logarithm. So we start with 4, come up and around x, and land on 16. So the first number we write is 4 raised to the x is equal to 16. Now we can go ahead and evaluate. This is just saying 4 to the what power equals 16. Well, 4 to the first is just itself. 4 squared is really just 4 times 4, which equals 16. So therefore, x is equal to 2. So if we punch this into your calculator, we should get out a 2. Now the other method, if you don't like the swoop method, and if I still had the same one over here, is that because they're inverses of one another, as long as you write the same exact base, but as an exponent or as the exponential, right? That's just saying, okay, well, now I have a base of x raised to this whole logarithm with the equal base. Because they are equal bases, they are allowing us to cancel. But what you do to one side, you do have to do to the other. So you also have to raise this z to have a base of x. So now once your bases match, they'll have y is equal to x raised to the z power, which is the exact same that we have over here. So if we were to do this expression once more over, we have log base 4 of 16 is equal to x. Well, I can recognize, okay, well, my base here is 4, so I'm going to write my 4 here. What I do to one side, I then have to do to the other. And that allows me to cancel my logarithm of base 4 with my exponential of base 4. Then my 16 drops. So I have 16 is equal to 4 raised to the x power, which is the exact same thing we had over here. I'll try and switch it up. So maybe one problem I'll do swoop, and then the next I'll do the inverse property. I'm a huge fan of the inverse property because what you do from the logarithm side, you can do again with your exponential side, except with your exponential, you actually have to write the word log. Right now, if we do not have something over on the left-hand side, we can actually assign it a variable. We can just call it x or a or y or a question mark. So I'll do the swoop method for this one. It's just going to swoop up and around. So we have 8x is equal to 1. So it's just saying 8 to the what power is equal to 1, right? So what power allows us to be a 1, right? Have a 1 come out. Well, anything raised to the 0 power is equal to 1. Let's try it again over here. Now I'm going to do the other one where we have what is this? Your inverse property. So we have a base of 5 here, right? So that just means I'm going to match it with a base 5. And what I do to one side, I do to the other. So it allows me to cancel my logarithm and my exponential. So I'm left with 625 is equal to 5 raised to the x power. So now I need to figure out, okay, well, what are some powers that I know? So we have 5 to the first is 5, 5 squared is 25, 5 cubed is 125, and then 5 to the fourth is the 625. So that just means x is equal to 4. We'll try just a handful more. I'll do maybe one more 16. I'll do 6. Yeah, I'll do this next row. All right, so let's try it again. I'll do the base again. So we have a log base 4, so I'm just going to match it. What I do on one side, I do on the other side. So that allows me to cancel, and my x drops. So x is equal to 4 squared. Therefore, 4 squared, well, x is equal to 16. Let's do it again over here. Maybe this one I'm going to swoop. So I'm going to actually, and even better, I'm not a huge fan of decimals, so I'm going to write it as its fractional counterpart. And when I swoop, I should get 9 to the 1/2 is equal to x. Well, if we have a fractional exponent, I'll just write x is equal to, or sorry, x raised a over b. We can write this as a radical. So we have the nth root of x to the a. So the denominator is the root power, and the numerator is just the power of your variable. So we can write this as 2 on the outside and 9 and 1 on the inside is equal to x. So then the square root of 9 is 3. And I actually might do one more of those. Let's see if there's another one. Let's do this one. Oh, number 27, coming in hot right after that one. So again, I don't like decimals, so I'm going to write its fractional counterpart. So I can swoop here, and it just says 4 raised to the x is equal to 1 over 4. So you'll notice that 1 over 4 is in the denominator. So properties of your exponents just says, okay, if we have x to the negative first power, or let's say negative, we'll say negative first power. If it's negative up above in your numerator, we need to drop it down into the denominator and then make it positive. And you'll notice that your exponent on top of this particular 4 is a 1. So we can go ahead and say x to the negative first power is therefore equal to 1/4 to the first. So x is equal to negative 1. I'll do just a handful more, maybe. I'm trying to find some unusual ones. Let's see, number 33. So we'll raise this to the base of x and that to the base of x. So that allows us to cancel. The 25 drops. So we have 25 is equal to x squared. So what does x have to be, right? What number squared, what number multiplied by itself 2 times gets you to 25? Well, x is equal to 5 in that case. I'll see if I can find another one. Let's do 32. We'll raise it to the x power. That allows us to cancel. It drops. So 16 is equal to x to the 4th. So what number times itself 4 times gets you to 16? Well, that would be a 2. X is equal to 2. So hopefully that's enough of a refresher if you're trying to convert. I would ask that you pause the video and practice these on your own, and I'm going to show you the answer key.